In this tutorial, we will find the concavity and inflection points using the second derivative. Find the intervals on which f of x is concave up and concave down. Find any inflection points. So f of x equals x plus 5 all divided by 2x minus 12. So when you see the word concavity, you should think of the second derivative. So since we're going to have to take the second derivative, we'll need the first derivative. So f prime of x is going to use the quotient rule. So I'll just remind you how that goes. We write low d high minus high d low all over low low. So low is 2x minus 12, d high 1 minus x plus 5, and then d low is 2 all over low squared. So after simplifying, I'll leave it to you to verify that we get negative 22 all over 2x minus 12 squared. So now we need to take the derivative of this to obtain the second derivative. You see a quotient, so we could use the quotient rule, but actually there's another nice trick we can do. We can move the bottom, 2x minus 12, to the top by negating the exponent. This is a nice way to rewrite it when the top is just a number, like having negative 22. So now the derivative is actually a lot easier to compute. So I'll just simplify this. Now again, I'm going to write this 2x minus 12 to the negative 3 in the denominator. Now to find the intervals where the function is concave up and concave down, we need to find critical points. In other words, we need to set this derivative, second derivative, equal to 0 and solve for x. So clearly the top can never equal 0. So now we only need to consider values of x that cause the second derivative to be undefined. So in other words, we want to know when the denominator equals 0 because we don't want those values. So 2x minus 12 cubed can't equal 0. So we can cube root both sides to get 2x minus 12 not equal to 0, and we're just solving for x. So we obtain x can't equal 6. Now using this value that we found, we're going to just place it on a number line. So there's 6, negative infinity on the left, positive infinity on the right. And we're going to make a sign chart. Now the first interval goes from negative infinity to 6. And the second interval goes from 6 to positive infinity. And we'll put the second derivative and then underneath f of x. So now underneath negative infinity to 6, that interval, we want to pick a number that lies in that interval and plug it into the second derivative, and we want to determine the sign of that answer. Remember that if the second derivative is negative at some value in that interval, then our function is concave down. And if it's positive, then concave up. So let's pick 0. 0 lies there. So if we plug 0 into the second derivative, we get a negative number, which means that the original function, f of x, is concave down. Now a number between 6 and infinity, let's pick 7. If we plug 7 into the second derivative, we get a positive number, which means that f of x is concave up. Now we have a change in concavity at x equals 6 because we're going from concave down to concave up. So you might think initially that x equals 6 is an inflection point. But remember that x cannot equal 6 because 6 is not in the domain of the function. Remember, it gives 0 in the denominator. So we would say there are no inflection points. And this completes the exercise.